Alright, h prime of 3. Well, h is f of x times g of x. So if I want h prime, I'm thinking, by the way, there's probably not room on this worksheet to work all of these because it asks 2, 3, 4 things all at once with no space to do it. So the derivative of h is not f prime times g prime. I've got to use the product rule, so it's the first times the derivative of the second plus the other way around, second times the derivative of the first. So if I want h prime at 3, I'm not going to put parentheses 3 on all of those. I'm just going to say all at x equals 3. That's not really mathematically the right way to write that, but it's the lazy way to write that. So, see if I have enough colors to color code all of this. So, f at 3. So make sure you're looking at the right graph, and then are we looking at a point or a slope? So for f, we just want the point. So graph of f, graph of g. I think I made a mistake on one of these yesterday when I looked at the wrong graph. That's the silly, that's the mistakes to make. So looking at the graph of f at 3, that would be right there. That function value is 1. And it says estimate, so obviously if we're reading off a graph, we might get different values. I think everybody would pick 1 for that, though. All right, next I need g prime at 3. Well, how am I going to get g prime if I'm looking at a graph of g? What's prime mean? Slope. So I want the slope of g at 3. So there's g of 3, but I want the slope right there. So I want, and this is where the estimate part comes in. As best I can, I draw a tangent line there. And then as best I can, I figure out the slope of that thing. So how many up and over? Okay, well, again, it's a bit of an estimate, so we may come to different conclusions here. But I think I've got mine at pretty close to 1/3. Maybe not exactly 1/3. Up 1 over 3. So I'm going to call that 1/3. If you drew yours differently and you got 1/2 or 1/4, that's fine. That's why it says estimate. All right, plus, back to my formula, g at 3. Okay, so just the function value of g at 3. That's right where we were, but we just want the y value there, so that's -1. And then lastly, we want f prime. So that's the slope of f at 3. So the slope of f, make sure we're at the right one, at 3. We already got the point there, but now we want the slope. It's negative. I noticed that much right away. You know, it'd probably be best if we used like a ruler or something to draw a better tangent line, but at least a straight edge of some sort. Let's see here. What do I think is a good tangent line at 3? Okay, what in the world is that slope? Well, I could just go, excuse me, over 1, up. It's a little less than 1. Over 2, up 1.5. This is not a good one. Over or excuse me, over 1, down 3/4. So I think I'm going to say it's negative 3/4. But I don't know. -1 might have been a better, just an easier pick to do. So 1/3 plus 3/4, whatever that is. Hey, safe stop. Let's be done right there. That's the estimate for our derivative at h. So the big deal there was two things. Well, a couple, maybe more than two. Make sure you use the product rule. Don't just do f prime times g prime. And then how to use the graph to find the point versus finding the slope. When do you use each one? Make sure you look at the right graph. All those kind of questions. Let's do a table question. So that would be from the back. So number 3. Let's see. That would just be f prime plus g prime. That would be product rule. We just did one of those. Maybe we should do quotient rule. So let's do 3c. It says for the following functions find h prime. Well, h prime, this is the quotient rule, and they've got it set up for me correctly in terms of who's f and who's g. So g f prime minus f g prime over g squared. And then here's another symbol that maybe we haven't used before. If you do a bar and say x equals 2, that's the mathematic shorthand way of saying evaluate this chunk of stuff at 2. So that's a way to get around putting parentheses 2, parentheses 2, parentheses 2, parentheses 2, parentheses 2, squared. So at x equals 2, I need to go find all these pieces, but the table gives me all those pieces. So it's just using the table and finding the right piece. So g at 2, they're all at 2, so that's nice. It's 4. F prime at 2 is 5. Minus f at 2 is 3. And then g prime at 2 is -2. This is just being careful. This isn't a hard problem. It's just make sure you're looking at the right spot. G squared. So g is 4, and 4 squared is 16. And you could save stop that if it was a free response question and be done, because the rest is algebra stuff. A simple, I don't know if that's simple, but a straightforward question like that is probably multiple choice. So let's clean this up a little bit. 20 plus 6 over 16 would be 26 over 16. That will reduce to 13 over 8. Let's do one more with the chain rule. Let's look at 4b. So another table problem. Still trying to find h prime of 2. But h prime, so this is chain rule, but it looks a little different because there's not actual functions there. They're just g and f. But it's the same process, like one layer at a time, one derivative at a time, and chain the derivatives together. So the outermost function is g. So I'm going to take g prime at f of x, right? Because they don't eat the wrapper and the candy all at once. You do the wrapper, and then you do the candy. So chain rule that to f prime of x. And then, since I've got this nested parentheses stuff, I think I better switch to go ahead and putting in the 2. Because I'm going to need to find f of 2 and then use that as the input to g prime. So this table may be a little harder because there's There's probably more stuff than we need there. F of 2. F of 2 is 5. So G prime of 5 times F prime of 2. So F prime at 2 is E. Well, that's okay, different, but whatever. E and pi are just numbers, so okay, we can deal with that. And then lastly, I need to figure out what G prime at 5 is. So G prime at 5, so be careful, not at 2, but at 5 is 7. So my answer then is 7E. So chain rule, but using a table. So tables and graphs, not excuse me, not too bad, but you do need to practice them a little bit just to get used to making sure you locate the right pieces and put them in the right spot.